Hey there, kiddos. It's Programming V5 with Mr. T. Hey, so right now we're going to look at sensors and take a look at what these things are and what they do and how we need to deal with them. I'll have further videos on the actual programming of them, but this is just going to be a basic overview. So the first little sensor we're going to take a look at will be a bump switch. That's what both of these are. Now, a bump switch literally is a push button switch right there that you can use as a bump switch, as a bumper or something to that extent. Think of a Roomba that runs around the house. When it bumps into something, there is something that is activated. It could be a bump switch. And when it actually presses in and it has a reading of 1, so when it's not pressed, reading of 0. When it's pressed, it's a reading of 1. So when it's pressed, this sensor sends a signal to the brain, and then it will, well, depending on your programming, it will cause something to happen. So, cool thing about this is, with the bump switch, this is the old one for the EDR, and this is the newer one for the V5. And both of them hook into the brain right here. You get to choose a port because they are 3-wire ports. So you've got the 3 males, and then you have the female port here. Oh, you can't see it over there. There we are. And you get to choose any of these ports to use. All right. So one of the neat things about it is you can actually program these to either A, work when it is bumped, pressed, and released. You can have it work when it's just pressed, or have it work when it is released. So if you were to have a pressure switch, kind of like Indiana Jones and Raiders of the Lost Ark, and or was it Temple of Doom? I don't know. Maybe y'all should watch them. Basically, there is a golden idol sitting on a pedestal, and when it is picked up, a button or sensor is released. So let's say the idol is sitting here, holding down, and it is released. Boom! And then there you go. Then all the crazy stuff happens, and the ball chases them and everything. It's amazing. So here we go. Little Harrison Ford plug there. All right, so those are also called digital sensors. The other digital sensor that is a simple on-off is going to be your limit switch. Click, 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 click. Super satisfying. Super satisfying. There we go. It actually says it on the back. It is a limit switch. Congratulations. There you go. Same concept. It is a 1 when it is pressed. It is a 0 when it is not pressed. So there you go on those guys. All right, so here we go. There's your other digital switch. And let's look at our analog switches. And you're like, all right, digital and analog, what does that mean? Your digital is an on-off. Your analog has a range. So you have here on the left is a line tracker, or it used to be called a line follower. This one right here is a potentiometer, also called a pot. So a potentiometer measures the range in basically degrees, so like a spin thing, okay? Like I said, I'm keeping this really basic. So it will measure how far something is turned. So you will start at one part, and then you will not go completely around. This thing will not turn 360 degrees. If it does turn 360 degrees, it would have something like this on there, because if you were in my class, because I would put a frowny face because you have now broken the inside mechanism of your potentiometer. So what that means is you have to be super delicate with them. And the way I usually have it for you guys, and the way that you can do with your programming, go ahead and just add a shaft in there, throw a gear on it, and just gently, kind of like this right here. Let me get that guy in there. And just slightly turn. Slightly turn. And that's it. Nice and gently. Okay? Just be super careful. If you put a motor on it, it will 100% break it. So just don't do it. All right? But that's your potentiometer. And when you do mount it, you'll mount it just like you would mount a limit switch or whatever. Just go ahead and put a screw and a nut right there on the sides. And have the VEX symbol up. Not the other way around. So this is what you want to be looking at. Okay? Okay, the next sensor we're looking at, this is the line tracker. All right, so this line tracker right here, It is an analog sensor, and it measures a range. But what range, Mr. T? I got you on that. So it actually measures brightness, or reflectivity to be exact. So it's not, yes, it can kind of tell the difference between colors, but it mainly finds the difference between the reflectivity of the colors or surface. So yes, you can actually have it choose between blue and yellow and red and other things like that. However, you have to find the exact reflectivity of those objects or those items that are that color. So yes, you can do a build to solve a Rubik's Cube with this. Yes, you can. So what I want to point out on this is since it measures brightness, how does it make a difference? Well, whenever it gets to a certain brightness, you can program it to do something. Whenever it gets to a certain darkness, you can program it to do something. Or again, more reflective object to less reflective object. What's crazy is, so if I were to program it right now, it would actually be on the darker stage because it's actually reflecting off the tiles in my lab, and it's not very reflective. However, if I were to put my finger over it, my finger actually, since it has oils on it, is more reflective than the ceiling tiles. So it would read my finger covering it up as brighter or more reflective than the ceiling tiles. So it's a little odd. It's almost counterintuitive. It's almost like you have to program it backwards if you are confused about that. But the main thing I want to tell you about the line tracker, I'm going to keep it basic. It measures reflectivity. So you have to find the tipping point of it. So imagine there's a line sitting right there. You want to cross the line. So highly reflective over here, less reflective over here. Well, you don't want anything to happen. You don't want your motors to run until it is a high reflectivity. So whenever it's less reflective on this side, nothing is happening in your program. As soon as a higher reflectivity is read by your line tracker, boom, there you go. Your motor turns and your robot takes off. All right, that's your basics of sensors. In a nutshell, super fast from Mr. T. Gotta go. See you later.